Lab 303. So for this lab, from the description, we know like we are trying to learn how to construct a star schema, and also we need to learn how to calculate the size requirement of a data warehouse, like which is similar with what we did in assignment 302. Yeah, so let's start it. So the first questions wanna ask to identify what is dimension, what is the methods, what is the grain, like the fact, which means the grain of the fact table, and also how to draw the diagram. So let's start. So since we've been learning this one-dimensional model for a while, I'll spend some time to go over with some main concept about the dimensional model and the star schema. And this is my slides, so we will start with here. Okay, so the dimensional model is a system that trying to support high volume query access. You know, we also learned the relational model, right? Like how to normalize like that. That kind of type of table is trying to support the high volume storage. They are the traditional model. But for this one, it's no longer need to be normalized. And the only thing we care about is how to run the query as fast as we can. So this dimensional model is trying to support the high volume query access. And so there are like different type of styles of dimensional modeling. For this one, we include like star schema and snowflake schema. So the star schema is the most commonly used and the simplest style of dimensional modeling, which also something we're gonna learn applied in this class. The snowflake schema, as you notice, it's just a dimension table I spoke of, right? So for these dimensions, we have more dimension table to explain the dimension data. So so this one is a little bit complicated than the star schema, but this star schema will be the one we're gonna focus on in this class. So let's take a deep look of the star schema. They have a lot of components of star schema. We can start with this fact table. As you're able to notice, the fact table including like two different things, different case and different methods. Okay, so go back to the star schema. After the fact tables, we also have dimension tables. And we have several different dimension tables. In dimension table, it's including the case and the attribute. Attribute means like different informations to explain the case, right? For example, maybe we'll say a location ID will be the key, right? The ID will be the key. And under this like location dimension tables, we might have where are we, like what, like the location, the address, state, or cities. They are the attribute of this dimension table. Next, we can say like the fact tables contains the factual and the quantitative data, which is the most important things we care about, right? And the dimension table can include like description and the subject of each different business. So the relationship between dimension table and fact tables is always one to many, which means like one of like values from the dimension table is contact could be multiple cells in this fact table. All right, so let's talk more about the fact and the methods. So fact, going back to this table, which means like the record, each record will be counted as fact. So it's referred to like different events and the transactions we try to record, we try to capture in the business process. So for example, in these tables, we have 3. So the first transactions, that's a fact. Second transaction, that's a fact. So they are the fact, and which including different columns, including several key values and the methods. And when we measure them, which is a method, it's referred to the quantitative or like numeric data that used to measure the performance, right? We can use the sales to measure the performance, or we can use the quantitative sold to measure this performance. It has to be numeric and it has to be addictive. Addictive means like they could be count, like you can sum them, you can minus them, or you can just add more. So both fact and methods will be represented in the fact table. Okay, so for the questions, and these questions ask us to find out what are the dimensions, how many dimension table you might have to make, and what is the methods. Let's start. So for these questions, it's from a vehicle requires, so they provide like the service to the customer. So for each service has service code and description. So the code and description is something to explain each service, right? So the dimension, we could count it as dimension. Code, attribute, they are the attribute in the dimension table, right? So I just highlight them while. Then let's continue. Each vehicle is serviced as a certain type, like vehicle. So vehicle is another dimension, right? We wanted to know like this different, how is a vehicle looks like. So vehicle, it might contains different types and different makes. So that is the attribute of this table, because they're trying to explain the vehicle, right? So when vehicle arrive at shop, a mechanic, so mechanic could be another dimension, right, related to the business process. So mechanic is also important. So we treat it as the dimension as well. And the mechanic gonna inspect the vehicle and provide diagnosis. So each diagnosis, so this one is the next dimension, right? So it's including the attribute. The attribute include the code of diagnosis and descriptions of the diagnosis. And the chief mechanic, say like maybe the mechanic could be separate, like be like a chief one or junior one, right? So it might depend on the how many years they've been worked in the shop. And something they care, so they care about the average cost of service, average time in service. So all these values will be the methods, right? The methods is numeric properties of a fact, that aspect that are relevant to the analysis. So what is a fact relevant to the analysis, right? So we care about like their costs, we care about their types. So now it seems like we got the answer, right? So dimension could including like service, vehicle, mechanic, diagnosis, right? So under each of dimension tables, we might also have several different attributes. So for service, the attributes gonna including code, description. For the vehicle, it'd be different type, different make, and the mechanic, and also could including several different attributes, maybe like the years, how many years they've been work, and also since they are like they have the name, right? Last name, first name. And moreover, the diagnosis could be have some attribute including like what is the code, what is the description. Oh, one more thing, I forgot. Did you say like we are trying to count the number of service for each kind of per week and per month? So what is that? So this one also could be one dimension table, right? The name, when we measure the different dates, we have the date dimension table, right? So which means like the dates could also be counted as the dimension. Okay, so now looks great. So that's question A. We have service, vehicle, mechanic, diagnostic dates as the dimensions. And for the measures, it will be include the cost of service, right? And the average time in service, number of service rows in the fact table. So they're not the measures, they're just like how many rows, the size of the fact table. So going back to the methods, we including the average cost of service, which is we care about for each record, right? For each record, like there's one record, it might including different vehicle, including different mechanic, different service, and also we care about their average cost and the average time they used to fix the problem. So that is the methods. Okay, so C, what is a fact? So for this one, fact, remember it means the record in the fact table, right? So we have different transactions could be count in the sales, right? So for these questions, the fact means a specific service visit, right? So that's one transaction. So this service visit might including different like columns. You need to different values you need to count. It depends on their service, depends on their vehicle, mechanic, diagnostic, time. These are the key values. And also we have how to measure it, the cost and time in service. So the fact here, which is again the service visit, including different values. Yeah, okay.